What follows is not investment advice. Do the smart thing. Put your money in your super fund and go to bed, but not before you eat your greens. Excuse my somewhat nasal voice. A flu has gravelled up my usually silky baritone. I'm Arthur S. Falls, and this is Beyond Bitcoin. Here we learn about these new currencies, tools, and economic systems by speaking to the people building them. Because you can do that now, just build a whole new economic system and rest on Sunday. My good friend Fuzznuts has been hosting developer hangout sessions on a Mumble server. You can find the details and recordings at beyondbitcoinshow.com. The second half of the show is an excerpt from one of those with Dan Larimer from Bitshares. Dan deserves a shout out for being so supportive of this endeavour, as does the Bitshares community as a whole. They've got a really great thing going on over there. Before we hear from those guys though, I'd like to take a look at some of the assets available on the NXT Asset Exchange. One of the looming developments in the cryptocurrency space has been this idea of crypto equity and representative tokens, and the recent launch of the NXT Asset Exchange has finally brought these products to the open market en masse. The NXT Exchange itself is an incredibly powerful tool, packed with all the real and bogus assets you'd expect. Hopefully we will have someone here to talk to us about the exchange itself, but for now I'd like to take the opportunity to breeze over some of the assets available to trade. By way of a disclaimer, I will use the terminology employed by the project developers themselves, but this is very new territory, and terms like share and digital asset still have some mileage to do before we can consider them fair descriptions of a representative token. BitHouse profit shares have been placed on the table by some of its shareholders. BitHouse is a centralized exchange, and it's been under development for a few months now. I honestly can't tell you what sets it apart, except that the guys at both Invictus and NXT have their fingers in the pie, so there must be some special gravy under the crust. These are unofficial profit shares, and I also don't know what binds the shareholders themselves to honour them. Except for their own reputations, of course. It may be that the profit shares themselves will ultimately be swapped out for actual shares when the avenues exist, but that's pure speculation. What this asset really represents is a unique investment opportunity and a chance for BitHouse shareholders to distribute stake while realizing some capital gains. Another exchange platform on the floor is Instant DEX. It's an effort to produce nearly instantaneous decentralized trading capabilities, employing NXT technology and off-chain settlements to tidy up some of the awkwardness of dealing on a blockchain. The exchange charges up to 0.2% per sign of a transaction, and it passes that on to the shareholders. Whether or not this operates as a DAC, I don't know, but it seems like a suitable candidate. As yet, Instant DEX is an incomplete technology, and it's pretty light on documentation. But as it approaches completion, we will likely get a better idea of how it functions internally and how it interacts with stakeholders. If there is someone out there who feels like they could explain at least the basic concept to a crowd, we'd sure like to hear from you. There are 1 million shares going for 28 NXT apiece as of this recording. Another fresh enterprise, NXT Coins Co. is a company presenting a new MetaCoin option to the public. It will use some as yet unimplemented features of the NXT protocol. The shares have been distributed to the individuals involved in the project, and it is those individuals who are divesting their stake. It's worthy of note that this is an actual company and these are actual shares. I see no reason why one couldn't issue and trade shares on the NXT Asset Exchange, but I do wonder about the legal back end of a move like this. If my understanding of NXT Coins Co. is correct, this may be the first example of a publicly traded company trading tokens representing shares on a decentralized exchange. Rounding out the old portfolio, tokens representing warehouse receipts for silver bullion are also available for trading. That should appeal to those precious metal fiends. Dots for Bits is a DNS marketplace boasting 1,000 TLDs and support for a plethora of cryptocurrencies. They also have a snazzy YouTube video with a dubstep soundtrack, which is something I always look for in an enterprise. Presumably there's a tie-in to NXT's DNS system there. It's yet another infrastructure piece we can get our hands on through the exchange. NXT Venture is just what it sounds like. A venture capital project that integrates promising ventures under the NXT Services umbrella. Dividends are paid in the acquired asset. Sounds like a great way to build a crypto portfolio without all that annoying thought and strategy that normally goes into these things. Okay, my favorite for last. SIA is an upcoming decentralized Dropbox. Users participate by contributing storage in 8 gigabyte increments, which equates to mining. The developers refer to proof of storage as a subset of proof of stake, which is interesting in that it separates stake in the network from wealth in the currency of exchange, which is in this case inflationary, forcing users to actually use it for its intended purpose, as a means of paying for storage, rather than as an opportunity for speculation. In the past, value in cryptocurrency has been thought of as first derived from speculative opportunity, and then once applied as a means of exchange from the economic activity that employs it. The key element in establishing that speculative opportunity is deflationary potential. The idea that tomorrow the currency will be worth more than it is today. This is the process that these Austrians we keep hearing about have a hard time wrapping their heads around. For those folks, a token of exchange must begin its life as an item of common value, deriving that value from some initial utility. They were demonstrably wrong on this point, but SIA's internal currency does fit the Austrian model. Storage can only be rented using SIA coin, which must be purchased from the miners. And there you have it, utility. For some reason I really get a kick out of this. 3.9% of the fees paid will be distributed among the owners of SIA stock, another proprietary token representative of equity. The asset being traded on the exchange right now is the SIA note, a stand-in for SIA stock which will be converted upon release of the completed project. Those are my favourites, but I suggest you go have a look for yourselves. I'm sure we'll be hearing more from some of these projects in due time. Next up we have the aforementioned Mumble Hangout session with Dan Larimer. Say hi to Fuzz for me.
This has been a very productive week in the Bitshares development. We've been actively pushing toward a delegated proof of stake implementation that is more than just accounting, but actually the delegates end up signing off on blocks. And I got a large part of that core infrastructure in place. But it's also resulted in some significant changes because we ran into some little details that they always get you in the end. It's the little things. These changes are going to have relatively far-reaching implications for what we're doing, and most of them incredibly good. So first, this is going to get a little technical, so I apologize for those in the audience that aren't quite so technical. I'll try to explain what we're doing and why we're doing it in a clear and concise way as possible. If you're familiar with Bitcoin, it uses a transaction model where you've got inputs and outputs, and everything is linked together. So in order to make a transaction, you find some balances from some unspent outputs, and you bring them all into the transaction, and then you have to redirect them to new outputs. And so if you want to spend a fraction of a cent, you have to bring in a full input, send the fraction of a cent to someone, and then send the change back to yourself. And that's the transactional model of Bitcoin, and that was the transactional model of what we were doing with the Bitshares toolkit.
So that has to do, just real quick, with the Merkle trees and the hashing of all transactions into the root.
This has to do with how transactions are structured, how they relate to one another. So the transactions are the database. It's a giant linked, in concept, linked list of following the money from out of one place into another, all the way back in history to the Genesis block. Right. And that's how you prove that money was not double spent, and is the basis of the Bitcoin blockchain and a lot of the clones. And that works very well if all you're doing is managing account balances. But we're trying to do a lot more than just manage account balances. We've got to register names, pay delegates, track votes, make decisions based upon the sorting of those votes. And then we've got all these other things we want to do, like issuing your own assets, managing shorts, longs, bids, asks. A lot of these other systems or other things that we're trying to track don't really fall into the input-output transactional model. And so what you end up doing is having this side database, this state that is outside of any individual transaction. So I guess the easiest way to compare and contrast it with Bitcoin, all the information needed for a particular transaction can be had by knowing your inputs and the data in the transaction. And you don't need any other context. That's it. But with these new systems, not only do you need to know your inputs, you need to know, all right, is this transaction voting for a valid delegate? Is the transaction a valid bid or ask? If it's registering a name, is the name globally unique? All these things are data that are outside the transaction itself and outside its inputs and its outputs. So what I'm doing here is just trying to lay out the conceptual thing of what's going on and how there's this paradigm where we're attaching this global state onto these transactions. And I started realizing, and this is the main challenge I had, is I want to pay the delegates, and they end up getting these micropayments every time a block's reduced, because it's just a small portion of the transaction fees. And there's actually no way for them to efficiently spend it because of the way transaction fees work. They'd have a whole bunch of outputs, and the cost of spending it would be the majority or more than the amount of their payment, at least when the network's small and growing. The other area where we had a similar challenge is Bitshares X. We want to allow transaction fees to be paid in other, like BitUSD, BitGold, and things like that. So there needs to be all this other accounting and things going on outside of the input-output model of transactions. So what we're doing, and I created a branch in the GitHub repository for this, is we're switching the mental framework of the blockchain slightly in a way that is greatly simplifying and greatly more powerful. And it's almost so simple that you're like, why didn't we do this in the beginning? And I can give you the answer why I didn't do it in the beginning, because I thought about it. And under the proof of work systems of the past, there were some significant challenges with it. And so I ruled it out and I didn't think about it anymore. So what we're doing is we're viewing the blockchain as just we have, imagine a giant database. And you want to modify this giant database. Well, the blockchain is just the log, the transactional log, the patches that you're applying to the blockchain. Perform this operation, do this operation, and it keeps the order. So if you want to roll it back, you can always reconstruct the state of the database by reapplying all of the transactions. That means that you can create a transaction now where some chains are starting to do this, where it's account-based. You transfer. I can send money out of one account to another account without actually having to specify a change address, because it just updates the database entries for the two accounts. And then you can make another transaction later, so it reduces the size of your transactions.
And this makes it more efficient.
Yes, it's more efficient because now I can define an operation that can modify an arbitrary number of records in the database without having to reference them all as inputs and create new outputs for all of those entries in the database.
Now, are there security implications for that?
The security is actually the reason why under proof of work I could not go with this model, and I was facing some challenges. And delegated proof of stake gives us a whole new option for lightweight clients. So let's consider this. One, all transactions have to be valid, and all nodes process all transactions and reach the same database state. So the security implications are the same. You can't spend a balance that's zero, or anything that would cause the balance to go negative. So that part is the same. But now we can have a transaction that says, I want to issue a new currency, and I'm going to issue it as this user ID. So you have an issuer. So it's kind of like a relational database. And my user ID can also be a delegate ID, or it could just be my ID in the system, my alias. So there's a way that we can tie all these things together. And then if I need to make an update and a transaction is going to have some fees, say I issue an asset and someone creates a transaction and doesn't result in some fees, right? They didn't allocate all the funds. They took money out and didn't put it someplace. I now can track that unspent balance of the transaction as accumulated fees. So I can have this database where for every asset, whether it's the core shares in the network or BitUSD or someone's personal IOUs that they're tracking, or say a MadeSafe IPO, they can all be tracked and monitored and updated as a result of the continuing regular transactions. And this is going into a lot of concepts, but the key thing I want to address here is that it boils down to this. The global state is just a database of records. You've got your various tables. You've got your name or identity table. You've got your asset table, and you've got your account balances table. And then you build some indexes on it. And the operations in the transactions perform updates on those tables, and they then they can be arbitrarily complex. One transaction can touch many different tables. But the key thing is this: I can then easily capture the changes to the database and undo and redo as necessary to handle forks in a transparent and extensible manner. And that was where I was facing some challenges, because if you have a transaction that's going to modify a delegate vote and simultaneously a bid or an ask, and all these things are going on, and there is a chain fork for whatever reason, and you need to reorganize the chain, how do you get that global database back into a known state? How do you undo things so you can back up to the fork point and start applying changes from there? And it ended up being a ton of custom undo logic that's not easily extensible, because any changes you make other places might end up impacting the state. So this really simplifies that down, and as a result, we've got a robust system for handling forks that we can then scale.
So what you're saying, what I'm gathering, and please tell me if I'm correct or where I am, is that you can actually roll things back and change things that have been, like if there's a hard fork, you can actually roll things back and not hurt fewer people in the process.
It's not so much about the hard fork, it's more about the network splits as a result of delegates going down, or cables being cut in the Atlantic, or maybe some attempted malicious attack. But what we were trying to resolve is what happens when, due to network issues, the delegates do not perform a consistent chain of nodes, and how do we handle all that? This is just standard fork management. It's more complicated in the Bitcoin sense, because Bitcoin, all right, we pop off the input outputs and then we reapply forward. But Bitcoin doesn't have this other global database with all these indexes and other full information that needs to be maintained and undone as a result of popping off these transactions. And so it was accounting and structure for undoing that was getting more difficult. And while you might be able to do it in this case or this case, it wasn't extensible or friendly for other DACs, whether it's the DNS DAC or voting DAC or whatnot. And if we started to add features, it made it harder to maintain going forward because, oh, now I need to undo this additional thing. I need to make sure I update the delegate counts to undo the votes that you applied as a result of this transaction. And that then affects so many other things. And if in the process of managing these forks, there's a bug, it could be catastrophic. So whatever we do here needs to be very simple, easy to understand and follow so that we have high confidence that it's done correctly.
So the main challenge is related to the fork reorg population block?
Right. This is all about handling forks and reorganization. It should actually simplify what you're doing, Hackfisher, with the lottery system, because now you can have a table that will track all these things, and you can use the same process to manage your undo and forks. And so I wanted to have a separate meeting with you and all the other developers like Nikolai or Toast in the forum to discuss the implications of this and how it affects the design moving forward. It's actually been, I recognize this and have implemented it since last Thursday, and it's gone incredibly quickly, and it makes it so much easier to write code, update it, and have confidence that it's right. So we will need to talk. It's currently in a branch right now. This is not going to be changing the API from the perspective of being Bitcoin compatible, the RPC, or anyone doing the web interface work. That's not changing, but this is going to affect the DAC developers.
Can you maybe summarize that again?
All right, so the solution is a transaction is defined instead of a set of inputs and outputs as a set of arbitrary operations. And these operations perform reads and writes to a set of database tables. And so what changed fundamentally is the nature of a transaction. It's not inputs, outputs, and summarize it, because that's too specific. If you're trying to do something more robust, trying to get to, say, an Ethereum style DAC, you need much more flexibility in what the meaning of a transaction is. So it's really, if you've done databases, if you think about a transactional database, you record a bunch of operations that you're going to apply, and you apply them all at once, and they either apply or fail. And they have, they log all the changes they're about to apply, and then if the whole transaction passes, then it writes it into the database.
And if it fails, then it does.
If it fails, it rolls it back.
And that's what you've effectively done.
Yeah, so I just, the concept of a normal transactional database, applied it to a blockchain as far as controlling which transactions should be applied and how they get rolled back. And before I apply a change, I save off, well, what was the previous state of all these records you're about to overwrite? And that goes into my undo history. And I maintain enough undo history to handle any reasonable length forks. I don't expect there to be a lot of forks, but we need to be able to handle internet issues when they come up and at least have a plan on how these things get resolved.
How many state changes are you going to be able to hold? Is it just going to be one, or are you going to have multiple snapshots over the course of time that, that maybe after like 100 snapshots, we know that everything is pretty much accepted, almost kind of like the block confirmations?
Just like a normal database, you can actually have a change on top of a change on top of a change and do partial rollbacks. So when I go to apply a block, I create one change set, and every time I go to apply a transaction, I create another change set, and I can just do a partial rollback and continue. And so I can look at the state at any time. Then, as far as block rollback, that's arbitrary. It's only limited by your space. So I'd probably put enough in there to handle what I consider any reasonable length rollback. And you could use some kind of heuristic for it based upon, all right, how many delegates have missed their opportunity to produce a block recently? All right, I'm going to keep more. And then if everyone's producing blocks and everyone's signed off on everything, then you say, all right, I guess I don't need to keep as much undue history because I've got signatures from all the delegates for however many days in a row. There's no possibility whatsoever of a fork at this point, and you can get rid of it.
So essentially, you could actually set it up so the network itself can assess the level of risk, all the delegates, and the delegates can then, based on that risk model they've assigned it at the time, they can expand that change state log, or they can make it smaller.
Right. The network has the ability to detect when a fork is in progress because half the delegates or a large number of delegates stop producing blocks. And when it detects this, it can alert the user and it can start saving undue state until it has clearly and unambiguously been resolved which way it will go. The fork management algorithm here, I've documented some of it with Doxygen and on our website, is relatively straightforward. We have a much easier time than other chains because we know exactly what the block interval is going to be. We know that each delegate can only sign one block per time interval, so you don't have to consider a lot of things. And it makes it very easy to say, well, highest block number is the best chain. And actually, no, that's the case. So I'm really happy with where we are. The problem is easily understood and analyzed for being correct. The challenges I always had with the other systems, whether it's Bitcoin or Peercoin, is how do you know someone hasn't produced a longer chain? You could have 3 or 4 chains going on in secret, and then bam, out of nowhere, here it is. What do we do with it? That's not really possible under delegated proof of stake. You can only have competing chains to the extent that a delegate failed to produce a block at the specified time. But because the expected delegates can't change that much by a single block, if one delegate says, I'm going to try to create a fork, no one's going to build off of his fork. And it's not like there's anyone else that can come along and extend his fork. So the only way to get a fork is actually having a network split of some kind. And so it's very easy to characterize the fork. You know, in theory, how many parallel forks you can have at a given time. And I'm very pleased with it. So we've been discussing it a lot, analyzing the corner cases. One of the things we posted as a refinement to the delegated proof of stake concept is that we're going to have an odd number of delegates. And the purpose of that is that in the case of the corner case where the network is perfectly split 50-50, that can't happen. One chain or the other is going to be longer because it's odd. And just that one little difference is enough to handle some of those corner cases.
So it sounds like a lot has happened in the past week. You guys have come to some necessary conclusions. Now, with regard to the test client and everything, how does that change the testnet, BTS XT?
The testnet was wonderful. It identified a lot of the challenges. One of the things that I got from the test network was that I was completely deluded to think that a trustee model with a single trustee was a viable way to even get started. If I'm not around, the network stalls. And if something happens and there's a problem, the client crashes or whatnot, the network stalls. The other thing I learned from it is, the problems people are having with their wallets. I was storing it as a flat file, and I was taking all the things to write out the wallet every single time into a temp file and move it in there, trying to make sure that was as robust and secure as possible. But the problem is there's either all or nothing. If anything went wrong when you were saving your wallet or anything got corrupted, you could lose everything in your wallet, and that is not something that we want. So this week we also moved the wallet to be a database so that we can update just the part of the wallet that's changing instead of having to go through and risk all of your wallet with every write to the wallet.
So your wallet itself becomes partially one of the store's actual change states.
No, it's not stored in the blockchain databases, but it's just using a database library to manage it. Bitcoin uses Berkeley DB to manage their wallet file. It just gives us more flexibility without having to worry about. What I wanted to do is, all right, every time you create a new key, you save the wallet so that if your client crashes, you don't lose the key you just created, or these things. But if you have to save the entire wallet and you start doing lots of operations, that starts to be a problem. So switch it to a database. Bitcoin had a database. I was trying to take a shortcut and just, define a JSON object, load and store it, and encrypt it. But so we switched that over to a database with individual records in it. We keep trying to release these minimal viable products that try to take a shortcut. Like, all right, well, we're going to launch it with delegated proof of stake, where we're only going to track the delegate votes. We're not going to actually implement all the delegate handling and have the delegates sign off on blocks. And what I'm realizing as a result of watching the test, watching the things that happened, is those shortcuts could result in a chain that we have to maintain that is insufficient. We have to work through all the details with the delegates, like how do the delegates get paid, so that we have it right. It's not just a matter of turning it on. If we're going to have to do a hard fork of Bitshares XT to address some of these issues, I'd rather avoid that, particularly if it's looking like it's going to have to happen on a shorter time horizon for what we're doing. So I think what we're concluding is that we want to have a more robust, complete system out the gate than a halfway completed system that then we have to support and then slows down real development, right? Because as soon as we launch a system, whether it's whatever the system is, we're committed to supporting that system. And any bugs or problems or user issues we have as a result of releasing a system too early ends up actually hurting forward progress, whereas we'd be better off fixing as many things as possible before we launch. And so that's what I'm learning from every time we release these tests. I start to see all the little issues people are having and recognizing that it's probably a bad idea to try to launch something more official. As Dan Notstein's always telling me, yeah, you can release early, but the bugs don't go away just because you released. You still have to pay the price and you still have to solve all the problems. You're just changing the effects from, oh, you're late, to, oh, I lost my money, or you compromised my private key, or something else. And then in the meantime, you're slowing down because now you're having to handle user requests and support requests, and you're in panic mode instead of carefully thought out developer mode.
This brings up a good point. And it's very interesting to see, because there are some of these projects that have released, right? And they're going to, like, it sounds like Dan is a good person to have around for you. If there are bugs or issues, it makes it very easy, due to the nature of the open source project, that somebody could just come out with their own fork and fix those bugs before you ever notice it, have a superior project or product, and kind of cut out the founding people in the original, right? So that would be a potential danger to releasing something before it's ready.
Yeah, there are a lot of challenges with releasing before it's ready. It's incredibly tempting, and I don't like having people breathing down my neck, and recognizing that, hey, we are doing major design updates and enhancements, and it's iteratively getting closer and closer to the proper complete solution. And no one wants this done faster than we do, but I look at these other projects and they're getting stuff done, and I commend, like, the next guys. They've they've got their client out there, and they got a lot of things implemented, and that's relatively exciting. But then you look at the pace of Bitcoin development and the rate at which they're adding new things to Bitcoin, and you realize that these changes take a lot of time.
Well, does anybody have any questions regarding that?
So I like the approach. I think it absolutely makes sense to take into account all the interrelated issues that might come up with the parts you not have developed yet, and how that might affect the whole system. Just what you said. So with that said, how many? That's a funny question. How many parts do you think are there which hold the potential for other obstacles that could take more time, like a further delay, another thing, the release?
Well, the good news is every single thing that we do, we make these changes, and it delays the initial release, but it's ultimately bringing all the future releases are being brought in. So it's we're adding more features. So when we initially talked about, all right, let's release something back in middle of March, it wouldn't have had name registration. It wouldn't have had asset registration. It wouldn't have had a lot of these things. So we're increasing the feature set simultaneously, recognizing that releasing a product, like, oh, we're going to build a car, but we're not going to have a muffler on it and no suspension. Some things, if you just don't put those features in there, it's just not a complete product, and it's going to have problems. So we're pushing back the date, but we're also giving more for the same period of time. So I think that ultimately people having to wait longer to get something in their hands are going to get more in their hands at the time to get it. So as far as the heart of your question of what other things or unknown unknowns or haven't we considered? And I would say that the single biggest thing that has been plaguing me throughout the entire development process is the fork management, and how do you handle forks and resolve it. And I am super excited that the fork management issue is just about solved and will probably be tested in the coming weeks. So by the time we meet next Saturday, I hope to inform you guys that we've tested it. We've done simulated forks with delegates that were elected in our tests, and everything was solid. And once we have that, I feel so much better about releasing something, because now I know that we can handle the forks. A fork is something that would kill a chain if you don't have a plan for handling it. And that's why we had the trustee, because, you can't get a fork with a trustee. But then, of course, the trustee can fail. And in our test, for whatever reason, the trustee did crash, and with a segmentation fault. And I don't know why it did that, but I want to make sure that trustees and the delegates now can automatically recover in the event of some bug like that. All right, fine, restart it, log it, and we'll try to figure out what caused it. These intermittent random failures are the hardest type to track down, especially in advance, because they work on all your unit tests and all your short-term tests. It's the long-term endurance tests that seem to be the problem. But Dan Notestein and Eric Frias are working to put together a unit test framework with. You've probably seen some of the graphs on the network. Have you guys seen those where we've shown how the network's structured, how messages are propagating across the peer-to-peer network?
That was something that did Toast put that first up on the forums?
I asked Dan Notestein to post the graph.
Roger. I have seen that one. I also saw one. It seemed like it was more interactive. It was like a web-based one.
I have two more questions, really specific ones that might be not as easily and specific to answer. But with all that said, and with all those new updates, what roughly is the timeline for the release? That's the first question. And the second question is, like you said, you will have enough. You will have a lot more features ready at the release. Does that mean that other DACs than Bitshares X, like DNS, Me Anyway, Music, and all those, can be released real quick after the Bitshares X release?
Yes, the other ones will be a lot closer. For example, I have the code in there now to issue your own custom assets in addition to just the straight up assets that are on there. The complexities associated with implementing the market for the bid and ask are much easier now. The ability to handle fees paid in alternative currencies like BitUSD, BitGold, that's a lot easier to implement with these architectural changes. So, when I'm making these changes, I'm looking at, all of them. So every DAC now has a name registration system. Every DAC is gaining a lot of abilities that they didn't have before. So it's really enhancing things. One of the other things we have going on in parallel to all of this is we got 3 guys working on a web interface, and that web interface is coming along rapidly. I would really like to launch with a working web interface that people can use. And I think that that's something we're going to have at launch, whereas all prior launches, we were saying that we're going to launch without such a web interface.
Now, with regard to this web interface, and are you going to have something on the wiki so people can actually go out and if they want to make their own custom modifications, it's more easy. It's easy for them to find exactly where they need to go, like a central hub rather than maybe just the forums.
Their own custom modifications to the web interface?
Yeah.
Yeah, it's just an HTML on your local computer.
So they can literally use like Google's inspect element to grab all the information.
Yeah, they can just point right at the directory. It's all JavaScript and HTML.
Is it possible to give a time frame within which Bitshares X and Bitshares Me, which I assume will come out at the same time? Is that correct? So a timeline or a time frame for the release of Bitshares X and Bitshares Me, and roughly when will Lotto and DNS come out, or is that not the right question to ask you, and we should ask Toast and Hackfish instead?
Well, Toast and Hackfish are responsible for their own release schedule, and of course, they're having to respond to my own changes. I can tell you that a lot of our developers are going to be coming online. They're finishing up school, ready to start working full-time in June. So just a couple weeks. Our development effort, the number of developers working on this is going to grow by like 50% or something. Because Nikolai or Toast is going to be full-time on it. And right now he's just working while at school. Now, he's been very productive while he's at school, but he told me he doesn't want to release anything or do anything until he's on it full-time. Hackfisher, he's on here, so I'll let him talk, but I believe he's planning on coming to Virginia to work with us for a couple months, and then he'll release after that. Based on where I see things right now, I would expect a lot of these things will be out this summer, with some things coming in earlier in the summer and some things later. But of course, I don't want to remind everyone that making our best estimates of where things are and engineering decisions are going to drive this, not release dates. It's really a balancing act between time to market, feature set, and being good enough, and also looking at the long-term costs of releasing something early. So that we have to balance all of these things, and I just want to make it one thing clear is that I am aware of trying to avoid engineering perfection and therefore never release anything. I don't want to go down that route, but Dan Notstein is a very experienced guy who's run a software company for a long period of time, and I have a lot of confidence that with the people we have on our team that we'll be able to get a solid product out there, and that we will be able to balance, identify what things need to be done before launch and what things can be done after launch, and get that out there as soon as possible with the right mix. And we're just doing our best. I said earlier, I'm not perfect. and I try my best to make the best call for this technology, and all the design changes or delays or anything that we do is just my best effort, and that's the only thing I can offer.
So you're not sitting there drinking champagne and in the hot tub?
Yeah, I'm taking all the AGS funds and just partying up. That's what I'm doing. Yeah, not actually writing code.
I asked that before 2 weeks ago or something, whether Bitshares Me will come out first or Bitshares X, and I got an answer, but I think I got 2 answers and they were contradictory. So maybe they can be answered.
Bitshares Me will come out first because Bitshares Me is a subset of Bitshares X.
Okay, and like how long roughly will Bitshares X come out after that?
I suspect that the delta development time, the amount of development time required to implement Bitshares X on top of the new architecture is going to be relatively small. So I would not expect we had all these months where we've been working on the core foundation of these DACs, and that's where all the effort is going into. Once you have the core foundation, the amount of effort it takes to create a new DAC is insignificant. I'd say it's 10% or less of the development effort. I think most of the Bitshares X effort is actually going to be on the user interface side, creating the charts and the market viewing things. But once I have Bitshares Me, I've already implemented the bid-ask solution once, and we are actually testing. I don't know if you guys remember back in January, I had a proof of concept going where you could place your bids ask, you could issue BitUSD and everything. And at that time, that proof of concept was looking very solid. And then we identified some security issues with the market, and I needed to add additional checks. And there were some feature requests that people put in at that time. So, but my point is that I've already demonstrated that the algorithm required for issuing the assets and doing the bids, asks, shorts, longs, and margin calls doesn't take very long to develop. I think I put that together in a week or two back then, and I would expect that it would only take a week or two to implement the blockchain mechanics, and then everything else is just the web interface.
Does anybody have anything else, or should we look at moving toward closing this?
I just want to encourage everyone to check out the Bitshares X status update 2.0 thread. I posted a link in there. Sometimes it helps to actually have a visual of the network that we are putting together and all the things we're tracking. And we have a really snazzy graph that Eric put together. This is from actual network tests. When we're debugging these things, we need to have insight into what the network topology is, how messages are flowing. That's more than just analyzing log messages, and it becomes incredibly complex. So if you want to get an idea of the level of engineering that we're doing and the analysis and just the complexity of the system, just go look at some of the graphs we have on here where we show network propagation of a transaction, which nodes it went to when, and the timing associated with it, as well as the interconnectedness of the peer-to-peer network. The fact that those graphs exist, you can see that we've got a robust system in place there. We've made a lot of progress.